anything off. So we are entering into the portions of 12th. So 12th oda idu vandu enter pannalam அப்படினு சொல்லிட்டு. So we have done with waves in the last class. So waves பத்தி பார்த்தோம். We looked at frequency, wavelength relationships. So அதெல்லாமே பார்த்துட்டு so today we are starting off with the 12th syllabus. So we are moving into it. So உங்களுக்கு வந்து basics வந்து I'll give you the basics எங்கெங்க தேவையோ. So I will be giving you. So இன்னைக்கு வந்து we are going to just look at a layman level. So அதுதான் we are going to do. Now we are not jumping into the advanced concepts today. So நம்ம basics எல்லாமே cover பண்ணிட்டு once we are ensured that all the basics have been covered, and then we will go to the advanced level topics. சரிங்களா? Okay, so let me share my screen. So screen வந்து ஷேர் ஆகுதான் செக் பண்ணிக்கோங்க. அதே மாதிரி ஆடியோ வந்து கரெக்டாக ஷேர் ஆகுதா அப்படிங்கிறதையும் செக் பண்ணிக்கோங்க. அனிமேஷன் வீடியோட ஆடியோஸ். So let me start off. Okay. So the tab நான் ஷேர் பண்றேன். So I hope the tab is visible. எல்லாரும் ஒரு வாட்டி கன்ஃபார்ம்.
Yes sir.
Yes. Okay. So this is the first chapter that we are seeing, electric charges and fields அப்படினு சொல்லிட்டு. This is the first chapter. It's very important. It plays a very important role also in the exam. So இது பார்க்கலாம். ஸோ இது நம்ம வந்து கான்செப்ட் போகிறதுக்கு முன்னாடி எலக்ட்ரிக் ஃபீல்ட் அப்படின்னா என்ன, எலக்ட்ரிக் சார்ஜஸ் அப்படின்னா என்ன அப்படிங்கிறது வந்து we'll have a small discussion. So what do you mean by electric charge? So anybody can tell me. So உங்களை பொறுத்த வரையிலும் electric charge அப்படின்னா என்ன? What you understand by the term electric charge or electricity, something like that. Electric charges நம்ம
property of that interacts with other.
Properties of, yes, you're right. Could you please repeat?
Property of matter that interacts with other.
Properties of matter that is interacting with other. Yes, in a kind in a way you are right. Properties of matter that is interacting. Yes, they try to interact. இப்போ for example, நம்ம எல்லாருமே வந்து real life situationsல we would have come across something called as static electricity. So everybody would have come across it. Static electricity அப்படிங்கிறது வந்து we would have definitely experienced personally. When you comb your hair and you bring the comb next to a bits of paper, it gets attracted. Yes, have you observed that? So why do you think that is happening? That is a phenomenon of static electricity. அது எதனால நடக்குது? ஏன்னா நம்ம சார்ஜ் பண்றோம். By combing hair, you are charging by friction. When two surfaces come in contact with each other, when they are being rubbed against each other, there is a charge that is induced in that substance. So because of the charge, the other particles get attracted. Small bits of paper get attracted. So on the mari, we can see that the objects get attracted when another object is being charged. So how do you charge objects? The objects are being charged due to friction. So when they are in contact with each other, when they are rubbed against each other, it can be charged. So these are examples of how charge can be induced. So நம்ம அதுதான் பார்க்க போறோம். So let me just bring you into that. So let me reshare. Okay. So we'll look at the basic idea. The first one we'll look at what is the electric charge. So electric charge na enna அப்படிங்கறத பார்க்கலாம். Just put it is getting loaded. So otherwise I will switch off to a different. Today the network is a little slow. We'll see. Okay, let me reshare. I think there is a server error. Okay, students will do one thing. I think there is a the site when there is server down at number. So let me just open the Blackboard. So today we'll stick on to the Blackboard model. So then reshare my screen. I'm sharing my writing pad. So tell me if you're able to see it.
Yes, sir.
Yes, you're able to see the writing pad.
Yes, sir.
Oh,
Visible, sir.
okay, okay. We'll go down. Set. So we'll stick on to this model today. So I will try to rectify it later. So that is a server issue mostly. So I mean, it has to be resolved on its own. Sure. So we will continue. 1 second. Okay. So we'll bring today's date. The new topic is electric charges and fields. So looking at this topic today. Okay. So நம்ம basics வந்து we are புரிஞ்சுக்க try பண்ணலாம். So what is meant by the concept of electric field or what is meant by an electric charge? So we'll try to understand. சரிங்களா? So electric charge na it is a scalar quantity where we talk about the particles of matter. Okay? So I'll just tell you. Electric charge is an electric charge. I'll just give you a basic definition. Is an internal property. So you define that as an internal property of subatomic particles. What do you mean by subatomic particles? It's an internal property of
Electrons.
yes. So subatomic particles can be your electrons, it can be protons. Electrons வந்து பெரும்பாலுமே they are negatively charged. So I'm putting that here, electrons, it can be protons. வெறும் electrons, protons மட்டும்தான் இருக்கா atomக்குள்ள?
Neutrons.
Yeah, we also do have neutrons. So electrons, protons, etc. அப்படின்னு போட்டுக்கலாம் general. So electrons, protons, it can be neutrons, etc. Which all objects are made up of. Okay? That make up all objects. So it will make up all the objects. So because of these charges, there is a force of interaction between each other. This results in a force of interaction. What do I mean by force of interaction?
Positive charge and negative charge are interacting.
Yes. So interaction அப்படிங்கும்போது இங்க that they can interact with each other. Or negative and positive can interact. Perfect. So you know that opposite charges attract. Like charges would repel. So what happened when I try to bring two electrons close to each other? Obviously electrons have a negative charge and they cannot kind of attach with each other. They cannot exist or coexist with each other together, or they cannot stick together. So that is not possible. So why? Because like charges repel. That is a property of charges. But the same thing, if I bring a proton and an electron, obviously they can get attracted. Why? Because unlike charges would typically attract. So that's the basic idea. So that comes from the properties of learn. Okay. So moving on. So inge vandu we understand what is electric charge. It's an internal property of what? Of subatomic particles. The properties due to which electrons, protons, and neutrons they can interact with each other. Then we have a force that exists between them. That force can be an attraction force. That force can also be repulsive force. So these are the two basic types of forces which can come into picture. When there is a force existing between them, you say that there is an electric charge which is present on them. Okay, so we'll definitely see that. Now the SI unit for electric charge, very important. Anybody knows the unit?
Coulomb.
Perfect. The SI unit of electric charge is called coulombs. It is represented by the letter C. Okay, C stands for coulombs. Coulomb அப்படிங்கிறது capital C யூஸ் பண்ணி நம்ம denote பண்ணுவோம். So that is the unit of electric charge. Now, for an electron, what is the charge possessed by an electron? Let us see. You can tell the charge of an electron. Whenever we do problems, we will use this value.
9.1 into 10
Not mass. Mass. Yeah, I'm not asking mass, I'm asking charge. It's 1.6 times 10 raised to minus 19 coulombs. This is the charge of electrons. Okay, the charge that electrons have. So that is what is meant by, this is the magnitude of the charge present on any electron that you take. So next, so the field of study that we are looking here is basically called electrostatics. Okay, first we'll look at what is meant by electrostatics. Statics. So electrostatics means it is a study. It is a field of study. Like how physics is a field of study, the same way electrostatics could have a field of study. So it is a study of electric charges present at rest. Electro means electrons, statics means rest. So we can break it. Okay. So we try to study the electrons at rest. So the study of electrons at rest is called electrostatics. So that is called as electrostatics. So there's a basic field, in which we study electrons which are kept at certain points. They are at rest. They are not in motion. When you try to study them, you call them as electrostatics. That field is as electrostatics. Okay, just the basic idea that you need to be knowing. Okay. Next. Now we will see how to basically produce the electric charges, how electric charges can be produced. We will look at that. First one, we will be looking at the different methods. That is for the methods of producing the electric charges. So that is called as charging. Okay. Methods of producing charge. Okay. Methods of producing charge. So we have different methods. The first method is called charging by friction. Friction, you try to rub the objects, and by doing so, you can induce a charge in them. You can bring a charge in them. Okay, that is called as charging by friction. So what is meant by charging by friction? So we'll try to understand this with an example. Okay. So I'll give you an example. So this is the method. So first I'll give you the definition. The method by which objects are charged by being in contact with each other. So by contact, you can try to charge the objects. Examples. So now we will look at the example for this. Okay. So you take a glass rod rubbed by a silk cloth. So a glass rod which is taken and which is rubbed by a silk cloth can get the charges. Okay. It can also get the charge. So what type of charge can it get?
Positive.
So we are trying to understand. Yes, so we will see that. So it is getting a positive charge. Which one? Is it the glass or the silk cloth? Which one gets a positive charge?
Glass rod positive charge.
Okay. So yeah, we are going to see that. Now when you try to rub a glass with a silk cloth, okay, now what happens typically is the glass rod is getting, you're saying that it is going to get a positive charge, right? Yes. Now how come it is getting positive charge? When a silk cloth is being rubbed, the silk cloth is going to basically lose the electrons. Now when you already know that when something is going to lose electrons, what's going to happen? So typically there is a positive charge which is going to get. So when you rub the silk cloth using a glass rod, so the object being rubbed would basically get a negative charge. Okay, the object which is coming in contact with the other would get a positive charge. That is the reason when I'm going to rub a glass rod, so let me just try to illustrate it here. So imagine this is your glass rod. So this is the glass rod, and then we have a silk cloth. So this is a silk cloth which I'm using for rubbing. So typically the glass rod is getting a positive charge. it experiences losing electrons, and hence there is a positive charge. At the same time, the silk cloth which was used for rubbing would get a negative charge. Very, very important. Okay, so it gets a negative charge. Now we all know that objects there is a law of conservation of charges. Initially, before I rub the glass rod and the silk cloth, there were no charges. But after I have rubbed them against each other, there is a charge. Now, what would be the amount of charges? They will be equal and opposite charges. If I have plus 5 coulombs on the glass rod, then what would be the number of charges in the silk cloth? It would be minus 5.
Minus 4.
Okay, because as per law of conservation of charge, the charges can always, charge can neither be created nor be destroyed. So therefore, it has to be equal and opposite, so that when you add them, you have to get 0, which was the charge before. So that you have to keep in mind. That is important. So எப்போமே charge வந்து நம்ம induce பண்ணும்போது, நம்ம create பண்ணும்போது, you're not creating something new. We are creating from what is existing. So therefore, glass rod is getting a positive. Say here, I am taking it as positive, plus 9 coulombs. Then your glass rod also will have a coulombs. How many charges? It will have minus 9 coulombs. So this is something that needs to be kept in mind. Okay. So this is how charges are induced by method of friction. By rubbing against each other, this is the method how you can induce the charges. This is the first method, first technique. Okay. Charging by friction. I hope this part is clear. How to charge objects by rubbing against each other. You can do it like this. Okay. So anybody is having any doubts, you can get it clarified. We'll move to the second method. Is it clear, this part?
Yes, sir.
Okay, great.
Yes,
so
sir.
now, so now we are moving to the next one. The second method. The second method, what we are doing is we are charging. We are going to charging by conduction. So we'll see how to charge two objects by conduction. Now, for this, to understand this, so first I'll give you the basic definition, how we can charge it. So in conduction, what we are trying to do is, so what do you mean by conductors? Before going to conduction, what is conductors? Conductors are objects which allow the flow of charges through them. Correct? For example, copper can be a conductor, your metallic spheres can be a conductor. Most of the metals are good conductors of charges. That is why they are good conductors of electricity, we say. So therefore, we try to understand charging by conduction. So adu purinjikalam. So what do you mean by the conduction? Okay. So we try to understand that. Fine. So this is the method. So I'll give you the method of charging an object. Okay, the method of charging an object by bringing a conductor in contact with another, by bringing a conductor in contact with another that has charge already present in it. That has charge already present in it. Okay. So what we are trying to do here, we are bringing a conductor. It can be a metallic sphere which has already a charge. Say it has a charge of plus 20 coulombs. So I'm bringing that plus 20 coulombs charge to another conductor which has no charge, meaning the charge is 0. So when you try to touch this plus 20 coulombs charge conductor with next to another conductor having 0 coulombs charge, now what would happen? The charge get transferred from the region of higher potential to the region of lower potential, or from the region of higher charges to the region of lower charge. So this plus 20 coulombs charge would get transferred to the conductor which had 0 coulombs. So there is a transfer of charges taking place. So you call that as charging by conduction. You're trying to touch it and then you're trying to charge it. There is no rubbing involved. There is no friction which is involved in this case. So this method is charging by conduction. So we will see this. So I'm going to suspend. So this is a rigid support. In a rigid support, what I am doing, I am suspending an uncharged metallic sphere. Now, what do I mean by an uncharged metallic sphere?
Charge is 0.
Yes.
Q equal to 0.
Correct. So, uncharged metallic sphere is taken. Now, what I am doing, do you remember initially how did we charge? We took a glass rod and we are charging it. You know that when you rub it against silk cloth, what is the charge on the glass rod? It was positive.
Positive charge.
Correct. Yeah. So we are bringing that glass rod now and I am going to make it in direct contact with this uncharged metallic sphere. Initially it's charged. I'll take it as Qi was 0 coulombs, where I is initial charge of the metallic sphere. Now, when I bring a glass rod which is charged, so what is happening? By making them in contact with each other, I am transferring the charge from the glass rod to the metallic sphere which was uncharged. So thereby, what's happening? The charge gets transferred from where to where? From the glass rod to
Glass rod to metallic sphere.
So what would be QF? Yes, what will be the value of QF, the final charge? Yes, so it will be say plus 15 coulombs. So if this had plus 15, here also you get plus 15 because it is getting transferred. That's it. So this is how you try to understand the charging, the process of transferring the charges by conduction method, where I am keeping it in contact with another object which has no charge initially. So you are trying to transfer the charges. Simple. This is method of charging by conduction. Simple. Okay. So now we are going to the third method. I hope these two methods are clear. So we are moving on to the third method. It is called charging by induction. Okay. So what happens in induction? Induction, you never touch it. Without touching it, you are going to transfer the charge. Okay. So we will write here the method of transferring charges. Okay. The method of transferring charges to a conductor without direct contact. Without direct contact with each other is called as charging by induction. So we will see how to basically perform charging by induction. Okay. Now, what I do here is, it's quite interesting to understand what is charging by induction. So this time I am taking the uncharged metallic sphere. So, governing is important. So uncharged metallic sphere, I am placing it on a stick, okay, which is also an insulator. Say on a plastic stick, on a plastic support, which is an insulator. This is an insulator. And this is a metallic sphere. This is a metallic sphere. So initially the metallic sphere is not charged. There is no charge for the metallic sphere. So yeah. So when I am taking it like this, now when there is no charge, you know that the Q is going to be 0 anyways, right? So 0 coulombs. Now what I am doing, okay, is I am taking two such uncharged metallic spheres. So say the first metallic sphere, I will call it as, okay, I'll take it as number 1, and the second one we will take it as number 2. So I'm taking two such metallic spheres. Okay, they are attached to insulators placed on the rigid support like this. So initially both of them are having a zero charge, no charge at all. Now what I'm doing, I'm taking a silk cloth and I'm going to rub ஒரு silk cloth எடுத்து நான் வந்து I'm going to rub the first sphere. அதை தேக்க போறேன். So what will happen to the first sphere? What is the charge that it gets? The first sphere gets, anybody?
Positive charge?
Positive
Yes.
charge.
Yes, so it is going to get a charge that is going to be positive charge. Yes. So it will get a positive charge. So in the Mari, it becomes positively charged. Okay, so Q is positive. Now say this charge Q is equal to plus 5 coulombs. Okay. Now this is charging by conduction, induction, or it is charging by friction. How did I charge it?
Friction, sir.
Very good. I charge by friction. Yeah. I have taken a cloth and I have rubbed it against it. So by rubbing, I have induced the charge. I have created this charge. So therefore, it is charging by friction. So by friction, the first sphere has got a charge of plus 5 coulombs. Now, what I am supposed to do is I am supposed to now charge the neighboring sphere without, bringing in contact with it, without touching it. So for that, what I'm going to do is, so I take another glass rod. Okay, so I take another glass rod. Now I'm going to charge that glass rod also. Okay, so when I'm charging that glass rod, so you know that the glass rod is going to become positively charged. So how is there any way by which I can bring negative charge into the sphere too? How can we bring in negative charge? Positive charges, we know how to do it. Just take a silk cloth and rub against it. But negative charges?
Positive.
Yeah, so negative is something opposite to positive, correct? So if you want to bring the negative charges, okay, so now what we do is, we are going to bring this uncharged sphere close to this charged sphere, but not touching it. So what I am doing, I am bringing this second metallic sphere close to the first sphere without direct contact. Okay, so then what happens? See here. So I'm bringing it very close to it, but not touching it. We know that the first sphere is having positive charge. What was it? Plus 5 coulombs. So the plus 5 coulombs charge is there. Now what happens is, when you bring an uncharged sphere close to it, you know that due to this charged sphere, now it is not in contact. So plus 5 coulombs is not going to get transferred to this, but equal and opposite charges are going to get created. Meaning negative minus 5 coulombs of charge is going to get created on the second sphere. So here we had plus 5, so I will write it there. On the second sphere, we have minus 5 coulombs which is created. Now how was this possible? There were two. There was an equal and opposite charge which was brought. Why an equal and opposite charge? We know that opposite charges would attract each other. Therefore, due to plus 5 coulomb charge, we could bring in the negative 5 coulomb charge on the second sphere. So totally if you add, it would be 0, which was the previous case of how the first sphere was. Okay, so when you add both, obviously we get 0. Okay, even the second sphere also is going to be 0 when you add the total charges. So net charges always would be 0 in this case. So that is what we try to understand. Okay, so this is getting negative charges. Now you can tell me how the second sphere is neutral. Still we have not completed. There is one part which is pending. Who can tell me second sphere is neutral. Second sphere la -5 coulomb charges தான் இருக்கு. ஆனா நான் 0 இருக்குன்னு சொல்றேன். எப்படி? How is it 0? ஏன்னா previous caseல பாத்தீங்கன்னா second sphereல வந்து சார்ஜே கிடையாது. first sphereல தான் சார்ஜ் இருக்கு. நம்ம அதை தான் சார்ஜ் பண்ணோம் silk cloth யூஸ் பண்ணி. பட் செகண்ட் ஸ்பியரும் நியூட்ரல் தான். எப்படி நியூட்ரல்? யாராச்சும் சொல்ல முடியுமா? ஓகே ஓகே நோ, that is not the reason. இங்க பாருங்க, இந்த +5 coulombனால there is a -5 equal and opposite charge which is created. That is clear. The same way here also opposite charges are there. +5 coulombs here also would be created in the opposite direction. They would get created. So therefore -5 and +5 would ultimately give you 0. புரிஞ்சுதுங்களா? So you will have +5 also which is created on the other end of the sphere. So left side I have put -5, right side there has to be +5. Only then don't you think you will get back this previous case 0? Q is equal to 0, isn't it? So therefore there is a opposite charge of +5 coulombs also in the second sphere. So this method by which you are able to create charges without bringing two conductors in contact with each other with a little distance apart from each other, you call that as charging by conduction, by induction method. Sorry, this is called charging by induction. So by this you can charge the conductors. Okay. Now what happens if I'm going to connect say I'm going to connect the first sphere to the ground? Grounding means you are trying to remove the charges safely to the ground. Grounding. Okay. So you would have heard about earth wires in the house. வீட்ல வந்து earthingகாகவே ஒரு வயர் கொடுத்திருப்பாங்க, green wire. So the wire extra charges எல்லாமே it will go down the earth safer. Same way I am connecting the first conductor to the earth. What will happen in that case? All the +5 coulombs is going to go to the earth. So what will be the charge after earthing? What is the charge on the first conductor?
0 coulomb.
It will become 0 coulombs. No coulombs at all. It will become 0. Yeah, it's 0. All the charges are going down the earth, so it will become 0. Okay, so that becomes 0. So when that becomes 0, so therefore what happens? The negative charges which were developed due to the +5 coulombs also would go away, and therefore the second conductor would have what? It would have only positive charge left while the negative charges go away. So therefore still you can see law of conservation of charges are holding good. Therefore it will retain only +5 charge, which was the case before. Okay, so that is still there. So like this you can understand or you can demonstrate the properties of charges by using the simple experiment. Okay, the law of conservation of charges can be beautifully explained by using, you can either use charging by conduction or by induction or by friction. Iதை யூஸ் பண்ணி நம்ம இந்த கான்செப்டை வந்து you can explain. Okay, so இது வந்து see if you look at this here, just basic idea of understanding of charges and their interaction is what we are learning. That's all. We are restricting our study to the interaction of charges between two objects. சரிங்களா? So the importance of this is not that much, but you have to know the basics. அவ்வளவுதான். சரிங்களா? So next what we are going to see is very very important. So this is a basic idea what we need to have. சரிங்களா? So now we are moving on to the next part. This is called as Coulomb's law. So அது வந்து we will go to the next one. So let me go to the page. Okay. So பார்க்கலாம். We'll see. Look at Coulomb's law now. Okay. இப்போ Coulomb's lawல வந்து so according to Coulomb's law, Coulomb's law என்ன சொல்றாங்க அப்படின்னா, when when two charges, okay, so when we say here according to Coulomb's law, when two charges say q1 and q2, when two charges q1 and q2, இப்போ நான் இதுக்கு வந்து sign கூட assign பண்றேன். I will give the sign, say plus q1 and minus q2. சரியா? When two charges plus q1 and minus q2 are separated by a distance of r in space. R வந்து is the distance between these two charges. ஓகேங்களா? By distance of r in space, then the force of attraction or repulsion, is, so இங்க வந்து ரெண்டு points இருக்கு. The first point is directly proportional to the product of the charges second point, it is inversely proportional to the square of the distance between the charges. The square of the distance between the charges. சரிங்களா? So this is what is the basic idea of Coulomb's law. இப்போ நம்ம என்ன பண்ண போறோம்னா, we are going to convert the Coulomb's law into a equation format. ஒரு ஈக்குவேஷன் மாதிரி கன்வெர்ட் பண்ண போறோம். ஸோ என்ன சொல்றாங்க Coulomb's lawல, ரெண்டு சார்ஜஸ் q1 and q2 எடுத்து நம்ம அது வந்து ஒரு r டிஸ்டன்ஸ் வித் அதை வந்து ஒரு டிஸ்டன்ஸோட நம்ம செப்பரேட் பண்ணும்போது the force of attraction or repulsion between them, so they are saying the force oda symbol என்னது? F. So F is directly proportional to, they are saying product of charges. நம்ம எத்தனை, how many charges did we consider in the first place?
Two charges, sir.
We have considered two charges. So F is proportional to q1 into q2. That is the first statement. First statement oda equation வந்து இதுதான். So we have converted the first statement into an equation. The same way, who can tell me how will you write the second statement? The force is again
F is proportional to 1 by r.
Force is inversely proportional to r square.
Yes, inversely now it is 1 upon or 1 by. So 1 by r square. So this is what is the second equation. Now what happens when I combine equations 1 and 2?
F is proportional to q1 q2 by r square, sir.
Yes. So when I combine equations 1 and 2, I finally get F is proportional to q1 q2 upon r square. So the force of attraction or repulsion between these two charges is directly proportional to the product of charge and inversely proportional to the square of the distance between those charges, or r square. Now, next step, நம்ம என்ன பண்ண போறோம்னா, I want to remove the proportionality sign. Now, if I want to do so, what should I do? Whenever you remove, perfect, you will introduce
Proportionality
a constant.
constants.
Yes, எப்பவுமே நம்ம proportional sign remove பண்ணும்போது you introduce a proportionality constant. So we'll take that constant as some k. So F is equal to k q1 q2 upon r square. So இப்படிதான் நமக்கு relationship கிடைக்கும். So what is this k? This k is nothing but the constant of proportionality. Okay. So constant of, we call this as the constant of proportionality. Okay. Simple. So this is how we write it. சரிங்களா? Now, இப்போ இந்த k தான் வந்து சொல்றாங்க, they are calling as electrostatic constant. This k is given by a value. So இங்க வந்து k has a value. K is equal to, we will represent this k as 1 by 4 pi epsilon naught அப்படின்னு சொல்லி எழுதுவோம். So you may be wondering, what is this 1 by 4 pi epsilon naught? 4 pi வந்து you know that 4 pi is a constant anyways. But what is epsilon naught? This epsilon naught is nothing. Yes, it is called as permittivity of free space. This is called as permittivity of free space. Is again, it tells to the extent that how free the space is. And what is a permittivity now? How easily the vectors can enter that area or forces can exist in that area. That is the permittivity of free space. It is a constant again. Ipo, this permittivity of free space has got a value. So epsilon naught has got a value. It is 9 into 10 power. We write this as 9 into 10 power minus 2. Approximate value I'm giving, not the exact value. 9 into 10 power minus 2 Coulomb square per Newton meter square. So that is the unit of SI unit of epsilon naught. So this is the value for permittivity of free space. Now this K itself can be written as, for simplicity, we take the values of K. It's found out to be 9 into 10 power 9. We always take value of K as 9 into 10 power 9 Newton meter square by Coulomb square. Okay. So inga pathingena reciprocal K and epsilon naught. Can you see where is K and where is epsilon naught? Don't you think they are reciprocal of each other? It is 1 by. That is why the unit for epsilon naught is opposite for the unit of K. It is when you reciprocal it, you will get the other unit. Okay. That's it. So this is the relationship. Yes. Yes.
Sir, permittivity value direct to 10 power minus 2 or minus 12, sir?
9 into 10 power minus 2 and we take it as the value, not minus 12. We are simplifying. எல்லாமே அந்த decimal place எல்லாமே simplify பண்ணி now just we are expressing as initially பாத்தீங்கன்னா 8.85 into something வரும். So we are not taking that value. We are taking this as 9 into 10 power minus 2 itself. After simplifying, after approximating, you are taking approximate value for easier calculations. Okay, but K value வந்து இதுதான். So this is the value of K. 9 into 10 power 9 is the value of K. சரிங்களா? Okay. So now we are moving on. So this is the thing. Now children, very coming to the important part. Now when I'm having two charges, இப்போ நான் questionல எடுத்த மாதிரி ஒரு charge வந்து plus Q1 எடுத்துக்கலாம். இன்னொரு charge வந்து minus Q1 எடுத்துக்கலாம். Okay. The distance between these two charges is R. Now you tell me the electrostatic force or the Coulomb's force that is interacting between these two charges, will it be attractive or will it be repulsive?
Attractive, sir.
Yes, it will be attractive. Why? Because this is minus and this is plus. Opposite charges will attract. So when I write my answer, I will say F is equal to minus Q1 square divided by R square. Are you getting it? I have taken two charges, Q1 and minus Q1. So it will be minus Q1 square upon R square. Not to forget, you have to put K also. So final answer will be minus K Q1 square by R square. Are you getting the concept? This is how you express.
Yes, sir.
This is an attractive force. Okay. Now we'll see a simple question. So I'm giving you one question to try. So based on this, so two charges, the question is, two charges, so Q1 is equal to 5 nanocoulombs and Q2 is equal to 10 nanocoulombs. Okay, is separated by a distance of separated by a distance of 12 micrometers. Estimate the force between them. Estimate the force between them. Yes, solve this and tell me the answer. Two charges, q1 is 5 nanocoulomb. Nano அப்படினா என்னன்னு தெரியுமா? You have to convert nano coulombs வந்து coulombs
10 power minus 9.
Very good. 10 power minus 9. Yes. So எப்பவுமே you convert the charges in terms of SI unit. SI unit வந்து nano coulomb கிடையாது, வெறும் coulomb தான். So you have to convert nano coulombs to coulombs. So 5 nano coulombs will be equal to 5 into அந்த prefix அதோட value போடணும். So 10 power minus 9. The corresponding factor for nano. So 10 power minus 9 coulombs. அதே மாதிரி what is Q2? You will write it as
10 into 10 power minus 9 coulomb.
yes, 10 into 10 power minus 9 coulombs, which is nothing but 10 power. Can we write it as 10 power minus 8 coulombs?
Yes, sir.
Yes. Adhe mari, what is R? Children, how will you write R?
12 into 10 power minus 6 meter.
Yes, micro means it is 6, minus 6. Good, minus 6 meters. So these are all the values. Once you have converted everything to SI unit, go and substitute in the formula. So here, F will be attractive or will it be repulsive?
Attractive.
Repulsive.
No, it is repulsive. No,
Repulsive, sir. Both are positive.
Yes, so it is a repulsive force that is interacting between both the charges. So F is equal to, going to the formula, K Q1 Q2 by R square. Now
Sir,
I'm
minus K.
why will minus come? Both are positive, right?
Sir, formula நீங்க மைனஸ் போட்டுங்க சொன்னீங்க.
ஃபார்முலா இது வந்து நான் கொடுத்த ஒரு சிச்சுவேஷனுக்கு தான் இது வந்து சொல்லியிருக்கேன். இங்க வந்து ரெண்டு சார்ஜஸ், ஒன்னு பாசிட்டிவ் இன்னொன்னு நெகட்டிவ். ஸோ அதனால பிளஸ் இன்டூ மைனஸ் மைனஸ் வந்தது இங்க. திஸ் இஸ் நாட் ஃபார்முலா. இது வந்து ஃபார்முலா நினைச்சுக்காதீங்க, இது வந்து ஃபார்முலா கிடையாது. this is for the situation which I gave. The actual formula exists here. This is the actual formula. And Q1 and Q2 appropriate நம்ம நீங்க வந்து இத பார்த்து எப்பவுமே பிளஸ் ன்னு போட கூடாது. That depends on Q1 and Q2. சரியா? Q1 பிளஸ் இருந்து Q2 மைனஸ் இருந்துச்சுனா then overall will be minus only. You know that plus into minus is minus, correct? Suppose yes, both are negative. Q1 negative கொடுத்து நான் Q2 negative கொடுத்தேன் அப்படினா, in that case what will be the overall charge?
Positive, sir.
Positive தான். Minus into minus plus தான். ஏனா both negative like charges will repel, no? So it is going to be plus only. சரியா? Okay. Now here, what is the value of K? K நம்ம என்ன substitute பண்ணுவோம்? 9 into
10 to the power of
10 power 9. Yes. Q1 Q2 substitute பண்ணுங்க. So
5 into 10 power minus 9 coulomb.
yes, அதே மாதிரி Q2 is 10 power minus 8.
Minus 8.
Divided by R square. Square பண்ணி போட்டுருங்க value. 12 square is 144 into 10 power minus 6 whole square. 10 power minus 6 the whole square. 10 power minus
36.
36 is wrong. It is 10 power minus 12, will ya? How will you get 36? 10 power minus 6 the whole square. How will you do this calculation? Minus into plus minus. 6 2s are 12 then varum. Okay?
Yes, sir.
Yeah, you must be careful in such places. Okay. Now you have to simplify this. So idu simplify பண்ணுங்க. So tell me what you're getting.
Sir, 10 to the power of 9 10 to the power of minus 9 cancel ஆயிடும் sir. போய்டும் sir.
Okay. அது வந்து போயிருது.
9 plus 45 sir. 45 into 10 to the power of minus 8 by 144 into 10 to the power of 12 sir. இப்போ 10 to the power of 12 மேல அதான் சார் இன்வெர்ஸ் பண்ணா நமக்கு வந்து 8 ல 12 போச்சுன்னா மிச்சம் 4 இருக்கும் சார். 10 to the power of minus 4 சார்.
So minus 12 வந்து நம்ம மேல கொண்டு போனோம் அப்படினா it becomes plus 12. Plus 12 minus 8 வந்து plus 4. Correct. So இங்க வந்து plus 4 இருக்கும். 45 divided by 144 அது நம்ம டெசிமல்ல வந்து கண்டுபிடிச்சாகணும். Or I think it is cancelling ன்னு நினைக்கிறேன். Just try 45 and 144. டேபிள்ல போகுது. 5 by 16 வருது எனக்கு. You're getting 5 divided by 16. Check பண்ணுங்க. இதுதான் simplified fraction. இதுக்கு மேல simplify பண்ண முடியாது. So you will get 5 by 16 into 10 power 4. Is it correct? Okay. அதுக்கப்புறம் 5 by 16 வந்து நீங்க இது பண்ணிக்கலாம், டிவைட் பண்ணி டெசிமல்ல போட்டுக்கலாம். 0 point something வரும். So 0.31 into 10 power 4 newtons. Is this the answer? Are you getting this?
Yes, sir.
Yes, sir.
Okay. இப்போ இதை வந்து நம்ம சயின்டிஃபிக் நோட்டேஷன்ல எழுதணும். சயின்டிஃபிக் நோட்டேஷன் என்னது? மினிமம் ஒரு டெசிமல் பிளேஸ்ல எக்ஸ்பிரஸ் பண்ணணும். ஸோ எப்படி எழுதலாம்? 3.1 into அப்போ 10 power, what will be the power of 10? If I write like this, 3.1 into 10 power 5 or 3?
5.
It becomes 10 power 5, isn't it?
Yes, sir.
Yes. Okay, so we can write it like this. So that is the final answer. That's it. Okay, so that's all about it. So I hope this type of questions now it is clear to you. So situation based ஒரு question நம்ம solve பண்ணி நம்ம பார்த்துட்டோம். Okay, so this is all about Coulomb's force. சரிங்களா? So now we are going to the next part. Okay, so I'm giving you one more question for you to try. It's a different model, so we are seeing that also. Okay, so forces okay. The question is three charges plus 5 coulomb, so plus 5 coulombs, comma, minus 5 coulombs and plus 10 coulombs are placed at the vertices of an equilateral triangle, okay, of length, so length கொடுத்துறேன், of length equilateral triangle of length 5 micrometers. Equilateral triangle of length 5 micrometers. So this is the figure. So the question is estimate the charge, estimate the force, I'll put it that way, estimate the force is experienced by plus 10 coulomb. Estimate the forces experienced by the plus 10 coulomb. இதுதான் question. சரிங்களா? மூணு சார்ஜ் plus 5 coulomb, minus 5 coulomb and plus 10 coulomb are placed at the vertices of an equilateral triangle of length 5 micrometers. இதுக்கு வந்து நீங்க ஒரு புக் வச்சுக்கோங்க, draw this figure, எல்லாமே மார்க் பண்ணிக்கோங்க, place all the three charges. Okay, so you can place the three charges. I will give you the figure. So adai mari you draw it. You tell me what is the charge on the plus 10 coulomb. Okay, so this is how it is. This is minus 5 coulombs, plus 5 coulombs, this is plus 10 coulombs. Saringla, this is the equilateral triangle. Okay, yes, just try this question. So plus 10 coulomb, with respect to plus 10 coulomb, you tell me what is happening here. Saringla, So just try this. I'll just give me a minute. I'll just go to the restroom and come. Just give me a minute. So try this question. Okay. Yeah. So அதோட forces எல்லாமே மார்க் பண்ணி வைங்க, நான் வரேன். Okay, just give me a minute. Yes, was anybody able to try it? How to do? Yes, children.
minus 5cu plus 10c equal to 4 கண்டுபிடிச்சிட்டு minus 5c plus 10c equal to 4 கண்டுபிடிச்சிட்டு ஆட் பண்ணிடுவோம் சார்.
எஸ், ரெண்டு. இப்போ ஃபோர்ஸ் வந்து உங்களுக்கு எல்லாருக்குமே தெரியும். ஃபோர்ஸ் வந்து இஸ் வாட் குவான்டிட்டி? இட் இஸ் a வெக்டர் குவான்டிட்டி இல்லையா? It has both magnitude and direction as well. So with respect to plus 10 coulombs, நீங்களே பாருங்க, plus 10 is positive while minus 5 is negative. So how will the force act? The force will act in this direction, yes or no? This is
Yes,
this
sir.
direction the force will act. Okay, so and the force oda value vandu you have to find out using the formula that we just learned. What is the distance between them? Equilateral triangle, all the distances are same, and you know the angles are going to be 60 degrees. So what would be the value of this force? So we will take this as, so ipo idu vandu charge 1, idu charge 2 and idu charge 3 nu eduthukitom appadina. So this force is acting from charge 3 towards charge 1. So we will write this as F31. So F31 force. Same way with respect to plus 5 coulombs. How will the force act? Will it act towards plus 5? How will that force act? Plus 10 க்கும் plus 5 நடுவுல இருக்கக்கூடிய force எப்படி act ஆகும்? That
opposite.
Yeah, that will act opposite like this. Why? Because it is repulsive, isn't it? So that you will write it as F32 or F23. How do you write it?
2 3.
Yes, F23 அப்படின்னு எழுதுவோம். சரிங்களா? So now you calculate what is the values of F31. Who has done it?
minus 10 power 4.
Formula F is equal to K Q1 Q2 upon R square. 9 into 10 power 9. Simplify பண்ணலாம். Q1 வந்து Q1 and Q2 plus into minus minus, so overall charge is minus 10 5s are 50 divided by R square. R square, what was the value? 5 micrometers. So 5 into 10 power minus 6 the whole square. புரியுதுங்களா? overall sign வந்து minus 9 5s are 45 into, you can write this as 10 power 10, கீழ வந்து 5 square is 25 into 10 power minus 12. கிடைக்குதுங்களா? I hope you have simplified the same way. So you will get this as 5 5s are 25, 5 9s are, so we can write it as 9 by 5 into 10 power
22.
how much? Minus 12, you bring it up, so it becomes 22. So 22 newtons. So 9 by 5 into 10 power 22.
8 into 10 power 22.
Okay, fine. Yes, you can do that also. That is that you can do it. So I wish to keep it like this. ஏன்னா question is still not over அப்படிங்கிறதுனால நான் இப்படியே ஃபிராக்ஷனை வச்சுக்கிறேன். ஏன்னா எனக்கு ஃபிராக்ஷன் வந்து சிம்பிளிஃபை பண்றது ஈஸி. So I will keep it as fraction. Who can tell me the answer for F23? Who has calculated F23?
Plus 8/5 into.
Is it the same thing? Inga minus varum, inga plus varum. Is it?
Yes, sir.
Yes, correct. Same thing only. Here plus will come. So plus 9/5 into 10 power 22 newtons. I hope you guys have got both the forces. இப்போ இந்த ரெண்டு ஃபோர்ஸோட ரிசல்டன்ட் தான் நம்ம கண்டுபிடிக்க போறோம். Okay, these forces were acting like this. So this was minus 9/5 into 10 power 22 newtons, and here it was plus 9/5 into 10 power 22 newtons. Now what is the angle between them?
80 degrees.
If this angle was 60 degrees, what will be this? 180 minus 60. Isn't it?
Right.
90 kadayadu. How will it be 90?
120 degrees, sir.
It will be 120, right? Linear. Apply the concept of linear angles. இப்போ நம்ம என்ன பண்றோம்? இந்த triangle நான் சொல்றது புரியுதுங்களா? This total angle is 180. Out of 180, this one is 60. So what is the balance angle? 180 minus 60 தானே? Yes. So it is 120 degrees. So you have two forces making two vectors making an angle of 120 between each other. Okay. So how can you find the resultant of these two vectors? You will apply the parallelogram law of vectors, which you learned. Okay. What is the parallelogram law of vectors? Resultant vector R is equal to under root of, or you can write total F is equal to also the resultant force is F1 square plus F2 square plus 2 F1 F2 cos theta. Have you heard about it?
Yes, sir.
Yes, sir.
Okay, you have to use the resultant of two vectors formula. Parallelogram law oda relationship தான் இது. So இது நம்ம யூஸ் பண்ணணும். Okay, இது substitute பண்ணி எனக்கு சொல்லுங்க, simplify பண்ணுங்க. Before that, what is cos 120? Cos 120 degrees lies in which quadrant? How can you express cos 120 in
Second quadrant, sir.
Second quadrant, sir.
Second quadrant. Okay, இதை எப்படி எழுதலாம்? Cos 120 நம்ம எப்படி எழுதிக்கலாம்? Cos of
90 plus
Cos 90 plus 30, sir.
yes. So 90 plus theta. Cos of 90 plus theta is cos theta or
Cos
sin
30
theta?
degrees, sir.
Cos 30 degrees, sir.
Yes. Okay, so appropriately we will write. But you have to be careful here. Whenever you write this, what is value of cos 30?
1 by root 2.
1 by root 2. sir.
Wrong. It is not 1 by root 2. 1 by root 2 is 45. Not 30.
Root 3 by 2, sir.
Root 3 by
2, sir.
2. Okay. I think you are all doing a mistake. See, cos 90 plus 30. Now this is going to obviously lie in the second quadrant. In second quadrant, what is that? All silver teacups. What's happening? in the
Sin
second-
theta வந்து plus ஆ இருக்கும், sir. Sin
ஆமா.
and reciprocal.
Okay. So therefore, all other values will change, isn't it?
Yes, sir.
So the other values will change. Only your corresponding sign and the corresponding sign, and then I think it is cosecant. Only that, though those both that values, the sign is going to change. The all others would remain the same. So therefore, how will you write cos of 90 plus 30? This you have already learned.
Minus cos 30 degrees, sir.
Minus cos 30.
In 30 degrees.
No, this is sine. Okay. This you should write it as sine. The ratio will change, right? The ratio changes. Okay. For cos, the ratio changes as sine. You should keep this in mind. So sine 30 degrees. Now, the value of this is going to be minus. Okay, sine 30 வந்து நமக்கு தெரியும், half அப்படின்னு தெரியும். But as per all silver teacups, only sine and its reciprocal will become negative. All others would be positive. So minus 1 by 2 is the value. Is it clear? இந்த மாதிரி நம்ம கண்டுபிடிக்கணும். For the maths, you should know the all silver teacups and the relationship is necessary. Okay. So accordingly, I am putting minus half. Sorry. So I go ahead and substitute now. So f1 square. So f1 square and f2 square. How can I write it? Simply we can say 9 by 5 the whole square into 10 power 22 the whole square into 2, because anyways I am adding them. Okay. So plus 2 f1 f2 cos theta. 2 into 9 by 5, again whole square, into 10 power 22 the whole square. Directly I am substituting, and cos theta value is minus half. So everything under root. Now what is common out here? So accordingly you can take common out. 9 nines are, I am directly, okay. First let me take common out and then write. Can't I take 9 by 5 times 10 power 22 the whole square as common out? If you open the bracket, inside you have 2 minus plus into minus minus, அப்புறம் இன்னொரு 2 and minus 1 by 2 இருக்கு. Cancel பண்ணோம்னா minus 1 இருக்கும். So 2 minus 1. Is it clear? This is what we have. Okay. 2 minus 1 is 1. So what is the final answer? 9 by 5 into 10 power 22 newtons is the answer. Same thing. You get like this. This is the resultant force. Same force, which is 9 by 5 times 10 power 22 newtons. So like this, you need to solve this type of questions. Is it clear?
Yes, sir.
This is the approach. Okay. So we looked at this type of question also. Okay. So now we are moving on to the next part. அடுத்தது வந்து we have electric field. இப்போ electric the force நம்ம பார்த்துட்டோம், Coulomb's force. So அதே மாதிரி now we are going to see what is electric field. Okay. So electric field ஓட relationship பார்க்கலாம். So what is meant by electric field? So trying to understand that concept. So electric field is basically, நம்ம field அப்படின்னா என்னன்னு சொல்லுவோம், magnetic field ன்னு வெச்சுக்கோங்களேன். How will you define magnetic field? நம்ம படிச்சதுதான் magnetic field. It is the region surrounding the magnet where its influence is felt. That is what is called magnetic field. Yes or no? Isn't it? So ஒரு magnet எடுத்துக்கிறோம். So when you bring some iron nails next to the magnet or small safety pins, it will attract it. Ana, only if you bring it in the magnetic field will it attract. If you keep it far away, can you expect the magnet to still attract it? Is it possible? Will magnet attract the objects, metallic objects, when they are kept very far from the magnet? Will it still attract?
No,
No, right? It has to be in the field. So field na enna? So we try to understand the field here. So the field is a region in space where the influence of a particular object is being felt. That is for magnetic field. The same way, here we say electric. So electric field in this case means it is a point, okay, or you can say it is a region surrounding the charge. It is the region surrounding an electric charge. It is a region surrounding an electric charge where, okay, where the force is experienced. Okay, where the force with respect to the charge is experienced. The force acting with respect to the charge is experienced. புரிஞ்சுதுங்களா? So electric field, it is a region surrounding the electric charge where the force acting with respect to the charge is experienced. You call that as electric field. Okay, so electric field அப்படிங்கும்போது obviously there is going to be some electric field lines also which are there. Whenever you take a positive charge, whenever I take a positive charge, the electric lines of force of a positive charge are always away from each other. So they are away. It is radially outward. Very important. This is the behavior of electric lines of force for a positive charge. Okay, so I'm writing it here. For a positive charge, the electric field lines, are radially outward. So this is for a positive charge. So Ade Mari, how will it be for a negative charge? For a negative charge, the electric lines of forces will be opposite. It will be radially inward. You know that charges are opposite charges would attract. So therefore, here it would behave the opposite way. So for negative charges, it will be radially inwards. சரிங்களா? Electric field lines are radially inward. Okay, that's it. So this is for a negative charge. So now when I have a combination of charges, for example, ஒரு positive charge அதுக்கு பக்கத்துலயே ஒரு negative charge வச்சேன் அப்படின்னா, so how will be the interaction between these two charges? You know that force of interaction is going to be attractive. You know, opposite charges will definitely attract, no doubt about it. But how will the electric lines of force, you know, be represented for a system of two charges which are opposite? So from the positive charge, the lines of force get deviated towards the negative charge. It will be like this. So it behaves like this. So for negative charge, you can see the lines of force always move towards it. And for positive charge, it is moving away from it. So this is the electric field lines for a system of two opposite charges. Okay, well? So this is how it is going to be when you have two opposite charges. Say we have two charges which are like. Say both are positive. How will it electric lines of force be for these two charges? Will like charges attract? Will they go and join?
Repel each other.
Yes. No. Yeah. They will repel each other. So it will repel like this. They will never touch each other. So it will repel. So they will repel. So this is how it looks for two positive charges. They will repel. So the field lines will never meet each other. Okay, you can see that they never meet. Okay, so therefore you can say that there is a repulsive force existing between them, and hence the electric field lines also never meet and they will repel each other. Okay, so this is the electric field lines for a system of two like charges For a system of two like charges, it is going to be like this. It will be a repulsive force. Same way, negative and negative எடுத்துக்கிட்டீங்கன்னா கூட இதே மாதிரி தான் இருக்கும். It's going to be repulsive. Okay. So this is all about the electric field lines. Yeah. So we looked at electric field lines, the basic concept, the definition. Or a positive charge, how the electric field lines are oriented. They are away from it. For negative charge, they are moving towards it. And it is radial. What do you mean by radial? Radial means it is equal in all directions. In all directions, equally it is spread for a positive charge, and equally on all directions it is entering for a negative charge. That's the radial in solvom. Okay, so in the charges mayama vechu all the field lines are going to either move towards each other or they would move away from each other based on whether it is a minus charge or it is a plus charge. So at the base panni you can easily identify. So this is all about the electric fields we have looked at. So next one we have a small relationship formula for it, and then we will go ahead. Okay, yeah, so for today I think this is enough. Okay, we will wind up here. Any doubts you have or any clarification needed, you can ask. So for the next 2 minutes, because if I start that topic, it will take time. Yeah.
Manish, I have only one thing to tell to our students.
Okay.
அது மட்டும் சொல்லலாமா?
Yes sir, yes.
இங்கே பாருங்கள் ஸ்டூடெண்ட்ஸ், ஏன்னா நீங்கள் அந்த இது படிச்சிங்க, இது எனக்கு தெரியுங்கிறனால சொல்கிறேன். எனக்கு நிறைய தெரியாது, பட் தெரிஞ்சது சொல்கிறேன். See, I don't know whether are you able to see this?
Yes sir.
2 power 3 போட்டு bracket போட்டு மேலே 2 power 3 whole power 2 அப்படின்னா அது 2 power 6. இப்போ 2 power 3 bracket போடாமல் மேலே 2 போட்டிருக்காங்க வச்சுக்கோங்க, கொண்ட மாதிரி 2 power 3 power 2 இப்படி போட்டால் அது 2 power 9. Am I correct, Manish? You correct me if I am wrong.
Yes uncle, that is correct.
இதில் என்னென்னா அந்த ஃபஸ்ட் இருக்கு இல்லையா 2 power 3 whole power 2, அதுதான் அதிகமாக வரும். 99.9% அதுதான் அதிகமாக கவர் ஆகும். ஐ மீன் நம்ம ப்ராப்ளத்துலலாம் வெரி ரேர்லி இட் இஸ் 2 power 3 power 2 விதவுட் ப்ராக்கெட் ரேராக பார்ப்பீங்க. அது ஆக்சுவலாக அந்த மேத்ஸில் அந்த இண்டிசஸ்ங்கிற சாப்டர் தான் வரும். வேறு எங்கேயும் ஃபிசிக்ஸ்லாம் அது அப்ளை ஆகிற மாதிரி எனக்கு தெரியல. ஐ ஜஸ்ட் தாட் ஐ வில் கிளாரிஃபை வித் த ஸ்டூடெண்ட்ஸ். சின்ஸ் ஐ நோ திஸ் சப்ஜெக்ட் லிட்டில் பிட், ஐ தாட் ஐ வில் பாஸ் ஆன் திஸ் மெசேஜ்.
Yes uncle, sure.
புரிஞ்சுதுங்களா குழந்தைகளா?
Yes sir.
bracket
So
இல்லாம
whenever you
போட்டா
have a bracket, you should be careful.
ஆமா, பட் அதிகமாக bracketோட தான் வரும். bracketோட வரும்போது it is you have to multiply, but bracket இல்லாம வரும்போது you have to really take the power.
ஆமா, அதே மாதிரி சைன் பாத்துக்கோங்க, உள்ள மைனஸ் இருந்து மேல bracket போட்டு சார் சப்போஸ் பிளஸ் போட்டிருந்தாரு அப்படின்னா ஓவரால் சைன் will be
minus.
Yeah.
Okay, this is a small information I wanted to share. Thank you Manish for your
yes uncle, sure.
yeah.